Hello, my name is Carter Colligan. This is a spontaneous lecture on the fluid mechanics of PC cooling, more specifically boundary conditions. Overall, PC cooling often uses water to cool the PC components like the CPU and GPU. A key component in this water cooling is the distribution block, which is used to spread out water and disperse heat and light, as shown on the right. The flow in this distribution block is driven by a pump. This pump creates a pressure difference in front and behind the water, which causes it to move. This flow is called Pacelli flow because it is pressure driven. In this lecture, we will go over the velocity profile of the water. The setup for this problem can be used during analytical or numerical solving. However, both numerical and analytical solving of this problem would require boundary conditions. Boundary conditions are a point on the velocity profile that we know are something to be true. In this particular case, we have two boundary conditions that we know. The first is the no-slip condition, meaning when a solid interfaces the fluid, there will be no slip, meaning the velocity at these points will be zero. So thus, at the top and bottom of the velocity profile, the velocity will be zero. Also, another boundary condition we know in here is because it's pressure driven, we know there will be symmetry, meaning at the midpoint of the flow, there will be no flux, meaning the change in velocity in the y direction will be zero. And using those two boundary conditions, we can set up the velocity profile. This is going to be the velocity profile that will result. In this, we can see both boundary conditions. We see at the walls, which would be at the y equals 0.5 and negative 0.5, there is going to be zero velocity. And we see at the top, there is symmetry and a zero derivative there. Thank you. Here are a few references.